Welcome everyone. My name is Grzegorz Chwypała. I work at Tilburg University in the Netherlands, and I will be talking to you about visually grounded models of spoken language and their analysis. I will start with the topic of automatic speech recognition, which has been quite a success story and within language technology. From your personal experience, you probably know that you can talk to a digital assistant installed on your phone or on some other device. You can do that in many languages, at least the major ones, and you can most of the time expect to be understood. We can also use ASR to automatically caption videos, and this is useful enough that if you need to switch off the audio and you just read the automatically generated captions, you can most of the time understand well enough what is being said that you can actually follow the video. So let's have a look at what ASR works like. And so the paradigm is relatively straightforward. What we do here is a task which is kind of a low level task. We take the audio signal corresponding to a spoken language and we transcribe it into text. And so we do this by training models on data, and this data is large amounts of transcribed speech. And so this particular paradigm and these features of it that I just mentioned, they're also in some way you can count them as limitations of ASR, in the sense that what we achieve here is the relatively low level task of transcribing speech, not of understanding actually what is being said. For that, we need another set of techniques, typically known as natural language understanding. And in order to train these models, we need quite large amounts of transcribed spoken data. And so that by large amounts I mean like in the range of thousands in the most cases. So that may be not available for most of the languages in the world, which are somewhere in the range of 7,000 or so, depending on how you count. ASR is working for the major languages of the world, but not for most of the languages. Uh, a further issue is that even some languages spoken by many speakers may not have a standardized writing system, so it's difficult to even go about creating this particular type of data. And one example of that would be Hokkien, which is spoken in Taiwan by many millions of people, but it does not have a standardized writing system. So when people want to write something down, they would typically do it in a related language like Mandarin rather than in Hokkien itself. So let's have a look at whether there is a different way of doing something similar, a different way of learning to understand spoken language. And so our model will be children, little humans. So how do they do this? Well, obviously they do it in pretty differently. They do not really learn to transcribe anything. They kind of do it end to end, as we call it these days in the machine learning context. So, uh, well, they pick up language by a variety of different mechanisms. We do not fully understand how exactly all of them work, but we have some ideas. We also Many of these are also just simple to observe from your everyday life interacting with children. But anyway, let me mention some of these mechanisms. So they use language internal statistics, such as like which sounds follow each other, which sounds occur together, or at a higher level, once they are able to isolate words, the same idea applies also, like what words occur together. That helps them build some meaning representations of those words. Uh, they also have access to the scenes co-occurring with speech. Typically, when children are being spoken to, there is something else happening, and usually or maybe not usually, but often this what is spoken is somehow correlated, or it refers to things happening at the same time. So they exploit correlations with objects and actions present and scenes co-occurring with speech. They also have access to clues given by the speakers, such as gaze and pointing. So what the speaker is looking at, are they gesturing towards something? This can often help narrow down the components of the scene that are relevant to understanding what is being said. And the more general idea here is inferring intentions of speakers. What do they want to communicate? What are they trying to do when they are saying something? Children can also play an active part in the conversation. They can actually ask for clarifications. They can ask for explanations. So when I say something to a child, she may ask, like, "What do you mean by that? I did not understand. Explain." And as I said, there are probably some other mechanisms which come into play, which we may not understand very well, but this is the general picture. So can we model any of this computationally? Well, some of these mechanisms rely on interaction with speakers, so adults typically, or maybe older siblings, and that is a pretty difficult thing to model for two reasons. So one approach would be that we would have a human in the loop, and we would have a model learn from other humans, interact with other humans in order to learn. That is maybe doable, but it also makes everything complicated and slow. Another approach would be to actually use an artificial adult, a model of an adult, but that kind of is give us a circular problem, because that's what we want to do in the first place. We want to have a machine or a system which is competent in language, if we posit that we need to already have one to build one, then that doesn't really get us very far. However, some of the other processes do not rely on humans or competent speakers, and so there has been some progress on learning from correlations with co-occurring scenes, and this particular mechanism will be the focus of my lecture. Just to clarify what is meant by that a bit further, we will rely on two types of input, on two modalities. We will have the speech signal on the one hand, and we will have a visual scene on the other hand. So, depending on the exact data that we're using, the visual scene may be a static picture or a video. The speech signal is going to be someone reading a description of that picture or describing it spontaneously. But that's the general idea. We are using these two modalities and the correlation, and we're trying to extract some information by finding correlations between them. And so in this scenario, what I like to call it is we have weak supervision. Okay, so and the reason that the supervision is weak is that there are at least two reasons for this. So the scene itself needs to be understood. We need to have or either learn or already have learned a perception, visual perception. So for this reason, the supervision is not very direct. And the second reason is that the correlations between the modalities are noisy or are weak in many cases, or unreliable. So we may speak about things which are not present in the scene. So if we look at this scene depicted here, maybe this the adult is talking to the child, and maybe she's talking about something which is not visible actually in the scene. Maybe there is a fire truck passing by, and she's talking about that sound. Secondly, we typically only will mention a subset of what is present in the scene when you're discussing something that is happening. So maybe the child and the adult are talking about the blocks, but maybe they are not talking about the table the blocks are on, or not talking about their clothes, or not talking about the window that is behind them. So these correlations are there, but they are not 100% reliable or always there. And so for this reason, this is a m- more difficult problem and a different setting than the classical ASR, where we have the speech signal when we have the transcription, and we know that the transcription corresponds pretty closely to what is in the signal. So to outline the lecture that is the content of the lecture that is coming up, I will first briefly talk about the history of this research, which started sometime in the early years 2000. I will discuss two papers from that period. And later on, I will go on to talk about more recent models, so modeling efforts starting in 2015. I will also discuss the issue of evaluation, and especially the issue of analysis, which is related to evaluation in the sense that we're trying to understand what the model is learning, how well it's learning it, and how it's representing things, and so on. What do I mean concretely with analysis? So these are some example questions that we may ask. What representations emerge during learning? Which components encode what? How much do these encodings match linguistic theory that we may have been using to describe language? What are good tools to carry out these analyses? So I will try to answer most of these questions later on. Finally, I would also like to thank my collaborators, all of them at Tilburg University: Afra Ali Shahi, Lieke Helderloos, Bertrand de Guy, and Mari Barking. Thank you.